download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about strong acids and weak acids. Now acids can be strong or weak, and we learned in the previous video that what makes an acid is when it dissolves in water, it ionizes, it produces H plus ions. Okay, so let me explain to you the difference between a strong and a weak acid by using two examples. So I'm going to use hydrochloric acid, I'm going to use hydrofluoric acid. Okay, they're the two acids that I'm going to use. So I've got two beakers here and two beakers of water, and I'm going to dissolve lots of hydrogen chloride into this beaker. Now when we dissolve hydrochloric acid into the beaker, it completely ionizes. So it completely ionizes. And what that means is all of the hydrogen and all the chlorine split up. They all ionize, they all split up. So if you see here, that makes lots of H plus ions and lots of Cl minus ions. Okay, we can see here that they've all split up, they've all ionized, therefore they have completely ionized, and this makes this a strong acid. On the other hand, when we place this hydrofluoric acid into the beaker full of water, what happens is that some of them do not ionize, so they do not fully ionize. So what happens is some of the atoms will split up and therefore ionize, so that should be a minus, and others will just stay together. Okay, so they do not completely ionize. And because we have now produced less H plus ions, these are weak acids. Okay, so really the main difference is that strong acids completely ionize when you place them into water. As we can see here, all the atoms have ionized, they've all split up, and that's a strong acid. Whereas weaker acids, when you put them into water, they do not completely ionize. Okay, some of them do, as you can see here, but lots of them do not, as you can see there, and that makes a weak acid. Okay, so reactions of acid involve the H plus ions reacting with the other substance. So if the concentration of H plus ions is higher, i.e. in this case here, the rate of reaction will be faster. So strong acids will be more reactive than weak acids. Okay, so the ionization of a weak acid is a reversible reaction, which sets up an equilibrium. So pH is a measure of the... Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Concentration of hydrogen ions. For every decrease of 1 on the pH scale, the concentration of hydrogen ions increases by a factor of 10. So let me just explain to you what that means. We have a solution that is pH 2 and we have a solution that is pH 1. Okay, there is a difference in 1 pH between these and these. Okay, so that means that pH 1 has 10 times more hydrogen ions than the solutions of pH 2. And solutions of pH 2 have 10 times more hydrogen ions than solutions of pH 3. And we can keep going. pH 3 have 10 times as many hydrogen ions as solutions of pH 4. But what that also means is that a solution of pH 1 has 100 times the amount of hydrogen ions as pH 3 and 1,000 amount more of hydrogen ions as pH 1. Okay, so for every increase on, or every decrease, sorry, of 1 pH on the pH scale, it increases the amount of hydrogen ions by a factor of 10. Okay, so obviously pH 1 and pH 0, they have the most hydrogen ions, and then they get gradually less and less by a factor of 10 as you go up the pH scale. Now this can be written as factor of H plus ions to changes by 10 to the power of minus x. And now minus x is the difference in pH. Okay, so let me explain this this thing here by using these two examples. Okay, so a scientist added a strong acid to a weak acid solution of pH 5. The pH of the new solution was pH 2. How many times did the concentration of hydrogen ions increase? So we want to know how many times of hydrogen ions, how much is it changed by? Now that's what we want to know here. Okay, so the change of hydrogen ions is equal to 10 to the power of minus x. Remember where minus x is the difference in pH. So let's put our numbers in. So originally it was pH 5, which is found here, and then it went to pH 2. Okay, now that means there was a change of minus 3 pH in this reaction, because it was pH 5 and then it was pH 2, so it went down 3. There's a minus 3 change. Okay, so to now work out the change in H plus ions, we do the change is equal to 10 to the power of minus 3, because it's minus anyway, and we've got a minus 3 here. Okay, which then makes essentially a positive. Okay, minus and a minus makes a plus. So actually the change is equal to 10 to the power of 3. Okay, and that is 1000. Okay, so 10 times 10 times 10 is 1000. So what that means is there was, or when the solution was pH 5 to now it's pH 2, it now has 1000 more hydrogen ions than it did when it was pH 5. So let's go through another example where scientists added a strong acid to a stronger acid of pH 1. The pH of the new solution was pH 3. How many times did the concentration of H plus ions change? So the H plus change can be written as 10 to the minus x, and minus x being the change. It started at pH 1 and then it went to pH 3. That is a change of 2. Okay, so that is a change of 2. So then we can put that into this equation here. So H plus change is equal to 10 to the power of minus, because it's a minus there, 2, because it's a 2 there. Okay, so the H plus change is 10 to the power of minus 2, which equals 0.01. Okay, 0.01. So how many times did the concentration of H plus change? Well, it changed by 0.01. So before we go on this video, we do need to just leave with the idea of the difference between strong acids and concentrated acids, because they are different and some people could view them as the same, but they are not the same. Okay, so for example, let's go back to our hydrofluoric acid that we looked at earlier. Okay, so let's go back to that hydrofluoric acid that we looked at, and let's put lots of that hydrofluoric acid into our water. Okay, remember some of them will ionize, but most of them will not ionize. This is therefore a weak acid. However, remember a concentrated acid is when you have more stuff, more of the solute in the water. Okay, so even though this is all not ionized, it still means there's lots of it in the water. So this could be considered a high concentration. Let's compare that to hydrochloric acid, and we're only actually going to put in one lot of hydrochloric acid, or 2 lots, let's put in. Now this will completely ionize, so it will completely split up, and therefore it's going to be a strong acid. However, if we compare the concentrations of our hydrochloric acid here to our hydrofluoric acid, there's less of them, and therefore it is a lower concentration. So hopefully you can see here that the strength of an acid and the concentration of the acid are two different things. You can have a low concentration, or you can be dilute, but you can be a strong acid. And you can be a weak acid, but have a high concentration. So what I'd now like you to have a go at is answering these questions here, and we'll go through the answers at the end. So pause the video now. Okay, so let's go through the answers. Sulfuric acid is a strong acid. Explain what this means. Well, it means that it completely ionizes in water, i.e. the atoms completely split up. They completely ionize, releasing lots of H+ ions. So they completely ionize in water. Which ions does sulfuric acid split up into? Well, the big ones is the H+ ions, and obviously you've got the sulfur negative ions as well. Okay, but H+ ions are obviously what makes it acidic. What is the difference between a strong acid and a concentrated acid? Well, a strong acid completely ionizes. A strong acid completely ionizes, whereas a concentrated acid means lots of the acid in a volume of water. And whether that means it's ionized or not, it doesn't matter, just that there's lots of it in a given volume of water. And finally, a scientist added a strong acid to a weak acid and the solution of pH 5. The pH of the new solution was pH 2. How many times did the concentration of H+ ions increase? Well, we can do the factor, or the change, is equal to 10 to the power of minus x, where minus x is the change. So it started at 5 and it went to 2, so it went down 3, that's negative 3. So you should have got H+ equals 10 to the minus 3, and therefore that the negative and the negative cancel each other out, so the change in H+ is equal to 10 cubed, and therefore the answer is 1000. So it has 1000 times more hydrogen ions as a pH 2 than it did at pH 5. So we've now looked at strong acids and weak acids. You can now look at the quiz and answer the exam questions on this topic. If there's anything you didn't understand, then please do get into contact with one of our tutors who will happily help.